I'm Anil Kumar. Welcome to my series on calculus. We'll review a few basic concepts. I've taken questions from previous test papers, and I hope this particular question will help you to understand rate of change better. The question here is, the shadow cast by a person standing 2 meters from a lamppost is 2.5 meters long. If the person is 1.8 meter tall and walks away from the lamppost at a speed of 210 meters per minute, at what rate is the shadow lengthening after 5 seconds? 4 answers are given to you. They are all in meters per second. Now, when you look into this question, first thing comes to your mind is to convert this rate of change into the units, which you look forward to, right? Then we'll actually also make a diagram to help understand the situation, form the equations and solve. Okay, so shadow cast by a person standing 2 meters from a lamppost. Let us say this is the lamppost for us, right? And let's say this is the ground. Now, the rays are coming like this. Okay. Here is a person whose shadow is being cast. It is given to us that the person is 1.8 meter tall, standing 2 meters from the lamppost. So this is 2 meters from the lamppost. 2.5 meter long is the shadow. So this part is 2.5. Correct. From this information, we can find the height of the lamppost. Clear? Okay. So let's find the height using similar triangles. So in such questions, we are basically using similar triangles. So if you look into the big triangle, h over 2.5 plus 2 is equal to 1.8 over 2.5, correct? So this ratio. So clearly this is 4.5, so h over 4.5 equals to 1.8 times 2.5. You can write height as 1.8 over 2.5 times 4.5, right? Let's find this height. 1.8 divided by 2.5, and we'll multiply this by 4.5 to get the answer as 81 over 25. Let's write it in decimals. We get 3.24. So height is equal to 3.24. All this is in meters, right? Okay. Now, let's also convert the speed. Well, let's define some variables now. So we want to find the rate at which the shadow length is changing, right? So this is shadow. This portion is the shadow length, right? Let's call this as y. We'll find, so if that is the shadow length, we want to find what is the rate of change of this shadow length with time, especially when time is 5. Is that clear to you? This is what we need to figure out. And as the person is walking away from the lamppost, we can say this is x, right? So we'll assume this to be x. As the person walks, x changes, shadow also changes. So these are the two variables. How do we relate them? Okay. Again, using similar triangles, we can write the height over x plus y equals to same thing, 1.8 over, this time it is y, right? Because that y is changing, the height of the person remains constant. So 1.8 over y. Does make sense to you? Perfect. Now we know the value of this h, which is 3.24. So we'll write 3.24 for h. So we get 3.24 and over x plus y, let's write like this, equals to 1.8 over y. Now we'll just cross multiply. So we have 3.24, we'll divide by 1.8, multiply by y equals to, take this on the right side, x plus y. So we have done a lot of stuff here. Basically moved this portion to the other side and this portion to this side. So it came y over 1.8. Is that clear to you, right? Mainly because we have so many numbers. Let's divide and get one number. 3.24 divided by 1.8 is equal to, we'll write 1.8 itself. So this is 1.8y equals to x plus y. So that's interesting. 3.24 divided by 1.8 will be 1.8. Right? So we can bring y together. 1.8y minus y equals to x, or 0.8y equals to x. Now let's differentiate with respect to time. So you get 0.8 dy dt equals to dx dt. Now here there is no term which is dependent on time, so this is a constant rate at which the shadow length is changing, right? So basically what we get from here is dy dt is 1.80, let me write down here. So dy dt basically is 1 over 0.8 times dx dt. Correct? So any time, whether it's t is 5 or whatever, it is dx dt is known to us, which is 210 meters per minute. So let's convert this to meters per second. That is very important. So let's do that. Okay, so let's do it here. So we have 210 meters per minute, right? To convert, we know 1 minute is 60 seconds. So let's do this part, which is 210 divided by 60 gives us 7 over 2, or in decimals 3.5 meters per second. Okay, so we should have calculated this value. Now here it is. So the dx dt is, so we know this is dx dt. dx dt is 3.5. Right, so this is the rate of speed at which a person is going. So we'll substitute this value here. So we get 1 over 0.8 times 3.5. So let's divide this 3.5 by 0.8 to get our answer, which is 35 divided by 8, or in decimals 4.375. which could be written as 4.4. Perfect. So we get option D as the right option in meters per second. Is that clear to you? So that is how we can actually solve this. Interesting part is that this length of shadow is really not dependent on the time. It is a constant rate at which it is changing. So such questions should be solved with the help of similar ratios. So I hope this is perfectly fine. Now here is a related question for you. In this question, we are asking at what rate is shadow lengthening, right? Now my question is, for the same question, part 2, at what rate is the tip of the shadow changing? So that is a very interesting question for you. So when I say at what rate is the tip of the shadow changing, in that case you have to look for the whole length, right? Not just y. That is the difference. So take this as your challenge question, solve and figure out what should be the rate at which the tip of the shadow changes after 5 seconds. Let me write after 5 seconds. Correct. So let this be the question for you. I hope you find it interesting and useful. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.